Algebra 3, Inequalities. So in Algebra 2 we were mainly focusing on equations where the left-hand side was equal to the right-hand side, and we were then using some sort of knowledge to try and solve the equation. So what does an inequality mean then? Well, it means that the term inequality can be that the left-hand side can be less than the right-hand side, or it could be greater than the right-hand side, or of course it could be equal to the right-hand side. So of course we need to look at some notation and a few terms with regards to the solution set before we look at some examples. So inequalities are a bit like equations where we can read left to right or right to left. But for the purpose of these examples, when I'm talking about them, I will be referring them from left to right. So the first symbol that we want to look at is this one here. And this one means less than. So when I'm saying less than, what I'm saying is that the left-hand side is less than the right-hand side. Because of course, if we were to read it the other way around, then it would mean the right-hand side is the opposite. In other words, greater than. Sometimes we see this symbol here, which means then it's a combination of less than or equal to. So again, what that means is that the left-hand side would be less than or equal to the right-hand side. If we see this symbol here, well, this means greater than. And again, when I'm referring to it, it would be the left-hand side is greater than the right-hand side. And of course, then we can have greater than or equal to. In other words, the left-hand side is greater than or equal to the right-hand side. So the easy way to remember these is if you lift up your left hand, and you make this shape here at the start, this one here, well, left-hand side is less than, which means then that this symbol here is going to be the opposite. It's going to be greater than. So again, this is a nice image from the primarythemepark.com, showing you again, easy way for remembering your left-hand side for less than and your greater than sign for the right-hand side. For the right hand, I mean. So in a lot of these questions you have the fine print, so the smaller things that we have to remember in terms of reading our mathematical symbols. So if we're given this in a question, it can't be ignored because the way in which we write our answer is dependent on what x is an element of. So here this means that x is an element of n, where n are the natural numbers. So the natural numbers are all of the positive whole numbers, 1, 2, 3, 4, to infinity. And remember that this does not include 0. So if we're asked to draw the answer on a number line, well then, how do we do that? Well, if I draw my number line and I start at 0, 1, 2, 3, 4, and if my answer is an element of the natural numbers, then what we have to do is use full circles on each of the numbers. So say my answer was x is greater than 0, well then if x is an element of the natural numbers, it would be 1, 2, 3, 4, and to show that it goes on to infinity, we would then put an arrow on the number line showing the direction in which it's greater than. So it's greater than meaning it's going to the right. But what if we were given something like x is less than 3? So if x is less than 3 and I mark in 0, 1, 2, 3 and 4 on my number line, to show that it's less than 3, I cannot include 3, and it can't be anywhere between 3 and 2 because that would not be a natural number. Everything between 2 and 3, there's an infinite set of numbers, and they are the rational numbers. The irrational numbers, in other words, all of the real numbers, can be found between 2 and 3, where 2 and 3 are also part of the real numbers. So if I'm looking at it just being a natural number and it's less than 3, then the only natural numbers less than 3 are 2 and 1. I have no arrow marked in here because there literally are only two possible answers, 1 and 2. We have to watch for this symbol here because this is also x is an element of the natural numbers, but this time there's a little 0 at the bottom of it. So what that means, it's all of the natural numbers and 0. So if we were doing the previous example there, x is less than 3, then we would have 0, 1 and 2 all circled in. So if we have x as an element of z, well, z means, so the integers are all of the positive and negative whole numbers. So again, if we're showing this on the number line, we only fill in with full circles, on the numbers. So again, it cannot include anything between these positive and negative whole numbers and 0 because they're all real numbers. So we can only put full circles on each of the numbers that are in our answer. If it's infinite in both directions, then this time we will put arrows on both sides. So say, for instance, if we have x is less than or equal to 1, well, I'll mark in 1, 0, minus 1, minus 2, and it's less than or equal to 1, so that means I'll include 1 in my answer because it can be equal to. And less than means it has to be a number smaller than 1, but it can't be anything between these positive and negative numbers. And again, because it's less than 1, it can go infinitely to the left. So I put an arrow to show that. So far in these couple of examples, we've looked at what x is an element of and drawing it on the number line. So when you draw it on the number line, you're showing the solution set on the number line, or you're graphing it on the number line. But the solution set itself would be written as, let's say, E is the name of the set, x is the element that we're looking at, and then we say x is less than or equal to 1, where x is an element of z. So it's the set of elements x such that x is an integer less than or equal to 1. So when we have x as an element of or, well, what does this mean? Well, we've alluded to this. This is going to be everything. So everything means the real numbers, the natural numbers, the integers, the rationals, and the irrationals. So how do we represent this on a number line? Well, if we have, for example, x is greater than 2, so we can mark in our numbers 0, 1, 2, 3, 4, 5. Well, if it's greater than 2, that means it cannot include 2. But this time, I have to put an empty circle on that because it's a real number. It means that it can include anything between 2 and 3. It just can't include 3. And therefore, we put a solid line this time for the real numbers on our number line. So it can be any number between 2 and 3, just doesn't include 2. It can be any number between 3 and 4, can include 3 and 4. And of course, greater than means it's going to the right. So it is every number between 2 and 3 onwards. So we say empty circle. As it's not equal to 2. So say, for instance, if I have x is less than or equal to 1, then it's including 1 this time because it can be less than or equal to 1. And again, less than means it's going to the left. And again, I draw my heavy number line because it's every possible number less than 1. So again, arrow showing the direction. So what would the solution set look like for that one? Well, we'd say, let's say, we'll call the set A. Then we would say A is the set of elements x such that x is less than or equal to 1 and x is an element of the real numbers. The type 1 linear inequalities. Solving a linear inequality is pretty much the same as solving a linear equation, but we have one special note to make So we have one special note to take into consideration before we look at solving these. And that's if we multiply or divide by a negative number, then the inequality sign reverses. So say, for instance, we have minus 2x is less than 4. We're trying to solve for x. So I would divide both sides by minus 2. Minus 2 is a negative number. So therefore, 4 divided by minus 2 is minus 2. But because I have divided by a negative number, then I must change the inequality sign. If I have minus a third is greater than 4, well, I could read that as either way. As I could divide both sides by minus a third, or I could look at it as multiplying both sides by minus 3. So if I multiply the left-hand side there by minus 3, I get 3 over 3, which is 1. And if I multiply 4 by minus 3, I get minus 12. But because I've multiplied by minus 3, or divided both sides by minus a third, then my inequality sign must reverse. So the answer would be x is less than minus 12. So here we're asked to solve for 2 times 3 minus 2x is greater than 2 times 3 minus x minus 6 plus x. What we have to note here is that x is an element of the real numbers. So this is going to tell us that if we're looking at the number line here, that we're going to use a solid line on the number line. So like an equation, we're going to start by getting rid of our brackets. So 2 times 3 is 6, 2 times minus 2 is minus 4x. That's greater than 2 times 3, which is 6, 2 times minus x, which is minus 2x, minus 6 plus x. I can't add the terms on the left-hand side. I can simplify the right-hand side there because we have 6 minus 6, which is 0, and minus 2x plus x, which is minus x. So bringing all the x terms to the left and all the numbers to the right, I'm going to add x to both sides. So minus 4x plus x is minus 3x. I'm going to subtract 6 from both sides. So on the left-hand side, 6 minus 6 is 0. And on the right-hand side, I have 0 minus 6, which is minus 6. Here I need to get x on its own. So I'm going to divide both sides by minus 3. We have to note that that is a negative number that I'm dividing by. And therefore, that's going to change my inequality sign. So that's going to become x is less than, and minus 6 divided by minus 3 is 2. So my answer is x is less than 2. To show that on the number line, well, less than 2 and a real number, and less than means I have to put an empty circle on 2 because it's not equal to 2. And less than means I'm going to go to the left-hand side and I'm going to draw a solid line because it is an element of the real numbers. And again, an arrow showing it's going indefinitely to the left-hand side, so heading towards infinity. Here we have some fractions in our inequality. We're going to solve and show the solution set on the number line. So just because there's a fraction here and it's an inequality, we treat it exactly the same way as an algebraic equation. So in other words, we want to eliminate our fractions. So to eliminate our fraction, we need to look for the lowest common denominator there. So the lowest common denominator between 3 and 4 is 12. So if I take the first term, I must multiply it by 12 to eliminate the denominator 3. I must multiply x plus 1 over 4 by 12, and I must multiply 12 by a third. So in other words, I'm multiplying the left and the right-hand side every term by 12, and that allows me then to get rid of these denominators. In other words, 3 goes into 12 4 times, 4 goes into 12 3 times, and 3 goes into 12 4 times. So that leaves me with 4 times x plus 2 is greater than or equal to 3 times x plus 1 plus 4 times 1. And now we have a nice, easy inequality to deal with. So same as the last time, we're going to multiply out our brackets. So that gives us 4x plus 8 is greater than or equal to 3x plus 3 plus 4. Simplifying the left-hand side and the right-hand side gives me 3x plus 7 on the right. Bringing my x's to the left and my numbers to the right. In other words, I'm going to subtract 3x from both sides. So subtracting 3x from the right-hand side will cancel the 3x. And then I'm going to subtract 8 from both sides. So subtracting 8 from the left gives me 0. And subtracting 8 from the right-hand side, well, I have 7 minus 8. So that's going to become x is greater than minus 1. So again, because I'm looking at x as an element of the real numbers, if I'm drawing this solution set on the number line, greater than or equal to minus 1 means I'm going to put a full circle on minus 1, and it's greater than, so my number line is going towards the right-hand side. So a nice big arrow and a nice solid line on the right-hand side. Sometimes the linear inequality that we're given is a compound inequality. So it's almost like two inequalities joined together. So we have 3 is greater than or equal to x minus 2, which is greater than minus 5. So we can look at this as two separate equations, or we can look at it all in one go. So in other words, if we were to separate that out, that could be read as 3 is greater than or equal to x minus 2, and then x minus 2 is greater than minus 5. So by separating it out, we then solve each separately and combine the answers then. So in other words, if I add 2 to both sides, we have 3 plus 2 is 5, greater than or equal to x. So in other words, that can be read as x is less than or equal to 5. So if I was reading left to right, 5 is greater than or equal to x. If I read right to left, x is less than or equal to 5. And the second half of the equation then, if I add 2 to both sides again, I have x is greater than minus 5 plus 2, which is minus 3. So therefore, our answer is x is less than 5 or x is greater than minus 3. Now, I could have done that all in one go, because if you look, what did I do? I added 2 to both sides there, and I added 2 to both sides there. So in other words, I could have just taken the whole inequality in one go and add 2 to each part of the inequality. So by adding 2 to 3, I get 5. By adding 2 to x minus 2, I get x. And by adding 2 to minus 5, I get minus 3. So in other words, 5 is greater than or equal to x, which is greater than minus 3. Or again, that could be read as minus 3 is less than x, which is less than or equal to 5. So that's normally the way we'd kind of read these inequalities. So if I was drawing that on a number line, what does it mean? Well, if I have minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and 5. Let's say x is an element of the real numbers. I forgot to write that at the top, sorry. Then if it's less than or equal to 5, it's going to be a solid dot on 5. And it's less than 5, but it goes as far as minus 3, and it's not equal to minus 3. So in that case, I'm shading a line all the way between 5 and 3, because it's x is an element of the real numbers. If it was a natural number or an integer, we would just be putting dots on 5, 4, 3, 2, 1, 0, minus 1, and minus 2, and none on minus 3. So in solving those compounds, you can do either method. It's whichever you prefer. Okay, so final example. Here we have two separate sets. So we have set A and we have set B. And we're asked to find the solution set of, that should say A union B. So we're going to find the solution set of A union B, and then hence we're going to graph it on the number line. So we're going to look at A first of all. So again, we note that it's an element of the real numbers. I'm going to get x on its own, so that means I'm going to have 2x minus 5x on the left-hand side. Subtracting 3 from both sides gives me minus 12 minus 3. And therefore we have minus 3x is less than or equal to minus 15. So dividing by minus 3, negative number I'm dividing by, therefore it changes the inequality sign. to greater than or equal to, and minus 15 divided by minus 3 is 5. So now if I do B, so again we note x is an element of the real numbers here. I have fractions, so I'm going to look at my lowest common denominator first. Between 3 and 5 is going to be 15. So that means I'm going to multiply everything across by 15. Making sure we're doing every term on both the left and the right hand side by 15. So 3 goes into 15 5 times, 5 goes into 15 3 times, and then I'm left with 5 times 9x minus 1, less than or equal to 3 times 2, which is 6, times 2x minus 4, and 15 times 2, which is 30. So I need to get rid of my brackets. So it's 45x minus 5, less than or equal to 12x minus 24 plus 30. And that should be 45x, sorry. So then we have 45x minus 5. Adding like terms on the right-hand side, well, I can only add the 30 and the minus 24. So that gives me plus 6. Bringing all my x's to the left-hand side. In other words, I'm going to subtract 12x from both sides. Bringing my numbers to the right-hand side. In other words, I'm going to add 5 to both sides. And therefore, that leaves me with 45 minus 12x is 33x, less than or equal to 11. And dividing both sides across by 33, well, 11 over 33 simplifies down to x is less than or equal to a third. So now if that's my solution for B, and my solution for A was x is greater than or equal to 5, if I look at A union B, and I want to draw it on the number line, so if we have x is greater than or equal to 5, and it's an element of the real numbers, then I put a full circle on 5, and a heavy arrow, solid line, going to the right-hand side. So it must be greater than or equal to 5. And then x is less than or equal to a third. So a third is approximately here. And again, it's a real number. So I can mark that in. And then less than is our solid line and an arrow to the right. So basically, if we're looking at that from a solution set point of view, what that means is that A union B is x is an element of x less than or equal to a third, x greater than or equal to 5, where x is an element of or. But if we were looking at the intersection, so just note, is there anything in common between these two solution sets? And the answer would be no, there is no intersection. So we say that that is the null set. And remember that the null set is our chain brackets with nothing in it, or a 0 with a line through it. So nothing in common. Okay, so let's see, what questions are you going to do? You're going to go to page 69 in your textbooks on active maths. And you're going to do question 1, 2, 3, 5, 6, 7, 9, part 1, part 2, part 4, and part 5, and question 11.